In today's video, we'll be using simulation nodes to create this abstract loop. I've been trying to create something like this for a very long time, but recently I just figured out how we could do it. So now I'm going to share it with you. In the default scene, I'm going to go ahead and first create the lines, which is going to be distorted. So let's bring our cursor to the junction of these two windows, click and drag to create a new window, and then change this from the 3D viewport to the geometry node editor. Then we'll press this plus button to create a new geometry node tree, and we'll zoom in, select the group input, and tap X to delete it. Now we'll press Shift A and search for a grid, and essentially we want the grid to be on the Y axis and very less on the X axis. So we'll change the Y scale to something like 5, and we'll change the X scale to something like 0.1. Then we'll plug this mesh into the group output to actually see what we have, and this is exactly what we wanted. The next step is actually instancing some number of points on this mesh that we created. So press Shift A and search for a distribute points on faces node, plug that in after the grid, and change this from random to poise on disk so that we don't have too many points present at this same position. To actually change the number of points on the same position, we'll change this distance min from 0.0 to 0.01, and then we'll increase the density max to get a huge number of points. Now I think the distance min has to be increased a little bit more, so let's change that to 0.1 meters. Now that we have this particular set of points, we can go ahead and just shift this back on the x-axis by a huge amount. So press Shift A and search for a set position node, and then plug this set position after the distribute points on faces node. For the actual offset, we can go ahead and just change this x offset to something like -15 meters. Now these points, we don't want them to actually remain on this singular plane. We want them to shift on the x-axis by quite a bit. So let's use another set position node by shifting this to the side, pressing Shift A and searching for a set position, or selecting this and pressing Shift D and plugging it after the first set position. For the offset, we'll change the x to 0, and we'll use a random value node to control the numbers. So let's change the min to something like -5 and the max to something like +5, but we want this only on the x-axis. So let's press Shift A and search for a combine XYZ node, and then plug this value into just the X socket while keeping the Y and Z as 0. Now we can take this vector and plug it into the offset of this set position, and now you can see how we have points present at different distances. Now on each of these points, we want to instance a bunch of lines. So let's press Shift A and search for an instance on points node, and then plug this in right after the set position. For the instance, let's press Shift A and search for a curve line, and then plug this into the instance socket. But the problem is that the curves are currently oriented on the positive Z direction. We don't want that, so let's change the Z value to 0, and we'll make the Y value to something like 10. Now that's still the wrong axis, so let's change this to the X with a value of 10. So maybe 10 is a bit too long, so I'll change this from 10 to 5, but I want to actually scale it up a little bit more to give it some variation on the scale as well. For that, I'll press Shift A and search for another random value node as well as a combine XYZ node. So I can actually take this and press Shift D, and this time I'll change the min to something like 0.5 and the max to something like 3, and then plug this value into the X socket, and then take this combine XYZ and plug it into the scale. So that way we have different lengths for the lines as well. Now ideally, I don't want the longest lines to reach anywhere between 5 meters from the origin, so it has to end somewhere around here. So for that, I can either change these values or the length of the lines to make it something a bit lower, maybe 4, but more than that, what I'll do is I'll change the actual position of these by changing this original set position. So let's make this -25, and that way these points are there 5 meters behind the origin. Now that's great, but I feel like all of the stretching is happening on the positive direction. So to fix that, on the actual curve line, instead of making the positive X as the only distance, I'll change this to 2.5, and I'll change the start to a negative value of -2.5. So that way the length of each line still remains 5 units itself, but it goes in both the positive as well as the negative directions. So I still don't like the distribution, but even though I don't like the distribution, that's all right, because if you actually change the seed value, you can see that it was just random, that it happened to look like everything is clustered towards the left hand side. Just by changing the seed, it's no longer clustered towards the left, so our setup is correct, and we will be controlling the seed by some other value later on, so I'll leave it as is for now. The next thing that I want is the simulation nodes section, where we'll get this to keep moving on the x-axis based on the number of frames that has passed. So let's shift the group output towards the side and press Shift A and search for a simulation zone. Let's plug the instances into the geometry of the simulation input, and then take the simulation output and plug that into the group output. Now within the simulation zone, we can press Shift A and search for a set position, and then simply plug it in between the input and output, and change the offset on the X by something really small like 0.1. That way when you play the simulation, you can see how it moves on the x-axis. Now I want this to be much faster, so I'll go ahead and set all of my defaults by going to my output properties, changing the frame rate to 30 frames per second or 60 frames per second to make it really smooth. And since I want this to be a 10-second long loop, I'm gonna require 600 frames, but because I want this to also be looping, I'm gonna double this and make it 1200 so that we can actually render between 600 to 1200 to get the 10-second loop. Now when you play the animation, you should get a realistic idea of the speed at which these lines are moving across the x-axis. So now now that we have that set, we need to add in new points after the first set of points have crossed this particular region. So to add in new points, we press Shift A and search for a join geometry node, and then simply plug in this instance on points instances into the join geometry. But if we do it just like this, every single frame, a new set of points will be joined in. And you can see that by going back to frame 1 and just playing the animation, there's a new set of points being created every single frame. We want this new set of points to be created only after the first set of points crosses this last region that these points actually reach. So for now, let's just remove this connection and replay the simulation and see approximately how many frames it takes. So I think as long as we make sure that the new set of points are added in after 200 frames, it should be good enough. So maybe we can make it 150 frames. Remember, whatever number you choose here has to be a sub multiple of the total number of frames that you're going to render. So since I want to render 600 frames, the number of frames that I choose here has to be a factor of 600. Since 150 into 4 is 600, I can't choose 150. Similarly, I could have chosen 200 as well, but I fear that if I choose 200, there might be a little bit too much of a gap. So I'm going to keep it at 150 itself, because a little bit of overlap is all right. So to make sure that this geometry is joined only every 150th frame, we can press Shift A and search for a switch node so that we can switch between two geometries. So the first socket will be the false value, which is whenever it's not 150. So we want just the original geometry to go right in. Then if the condition is met, which means the frame is a multiple of 150, then we need to join in these points as well. So let's plug this into the join geometry and plug the join geometry into the true socket. Now to actually control this true socket, we can press Shift A and search for a scene time node, and we can check if the frame number is equal to 150 or a multiple of 150. For that, we search for a math node and we change the type from add to modulo, which divides it by some number and returns the remainder after division. So let's plug the frame into the first socket and change the second socket to 150. So now whenever the number is a multiple of 150, it will be returning a value of 0. So let's press Shift A and search for a compare node so that we can actually compare if this number is 0 or not. Let's plug this into the first socket, change this from greater than to equal, and we're going to check if it's equal. So now we can take this result and plug it into the switch node. And now if you go ahead and replay the animation, you should see that after frame 150, we get another set of points added in. So that's exactly what we get. But we don't want it to just be the exact same set of points. We want the randomization to occur. So now we're just going to randomize everything. For that, we can press Shift A and search for a scene time node over here as well. And we can use the frame number to go into the seed for all of the different randomization seeds that we have in all of these sections. But remember, because we want this to loop every 600 frames, we need to make sure that the seed value becomes the same every 600 frames. For that, we can press Shift A and search for another modulo node, which is a math node set to the type modulo. And then we can take the frame and plug it into the first socket and change the second socket to the number of frames which you want it to loop at. So we want it to loop every 600 frames, so we're going to keep the value at 600. Again, this value could technically be a sub multiple of 600 as well. So 300, 200, 100 would all work, but that way there might be some repetition and we don't want any repetition. So we're going to keep it at 600 itself. Now we can plug this value into the seed for both the distribute points on faces node as well as the random value on the set position node. We can also plug this into the random value for the scale node. But right now, if we plug in the same seed for both the set position as well as the scale, what's going to happen is that the points that are present towards the far end are going to be scaled by a smaller number, and the points that remained towards the center are going to be scaled by the same amount. I don't want that. I want it to be much more random. So to just change the seed, I'll press Shift A and search for a math node, and I'll keep it at add, but I'll change the second value to some random number. Let's go with 100, and now it's going to be more random. Similarly, if I don't want to use the same seed for the distribute points on faces as well as the set position, I can actually take this add node, plug it in here, and just give it a different number, maybe 200, and that way it's going to be completely randomized. So now if I go to frame 0 and then just replay the animation, you should see that at frame 150 we do get a new set of points, but it's completely random compared to the first set of points. So that looks perfectly all right, and every single time we get a new random distribution. Now I do feel like the distribution over here is actually becoming too less at some points of time. So instead of making this modulo 150, I'm going to change the modulo value to 100 so that there's a new set of points added in every 100 frames. So now we can just play the animation again and see what happens. Now you can see that there is a little bit of overlap between the different sets of lines that we are adding, but because we're using a random seed every time, the overlap is not exactly happening on itself, and that's why it doesn't really look like it's too much of a problem. We do have slightly lesser dense areas and we do have slightly more dense areas, but more or less it's very random, and I like this distribution. So this is is the distribution that we're going to go with. But if we just let this play, you see that we get points going all the way to infinity, and we don't want it to go to infinity because we're just going to be creating a 5 by 5 meter over here and looking at only this section. So if a point crosses that section, we can just delete it. So we can shift this over to the side and press Shift A and search for a delete geometry, and then change this from point to instance because we want to delete the entire instance if it crosses a certain value. So let's press Shift A and search for a position node so that we get the position of these points, and we have to find the X position. So let's press Shift A and search for a separate XYZ node and plug the position into the vector and check if the X position is greater than a certain value. For that, we need to search for a compare node, and we want to compare this X value with maybe a value of 5, and if it's greater than, then the result will be true and it will be deleted. So let's plug that into the selection and then bring the timeline back to 0 and replay the animation. So you can see that everything starts getting deleted as soon as it crosses 5 meters, but clearly that's not enough because we need all of these to be present. So let's just increase this from 5 to something like 15, and now when you replay the animation, it should get deleted only after it crosses the area of interest that we have over here. So as you can see, it's starting to get it deleted over there. That's perfectly all right because we're only looking at this region, but just for safety, we'll increase this to 20, and that's even better. That's all there is for the simulation zone section, and now we can start off with the actual raycast region so that we can actually create the shape that we want. We're going to do all of that outside the simulation output, but first we need the actual target geometry to which these lines are going to be projected. So let's press Shift A and search for a mesh plane, and then let's scale the mesh plane up by 5 units so that we get a 5 by 5 meter cube plane, and then we'll press GZ and just bring it down by a little bit. Then let's press this plus button to create a new geometry node tree on this mesh plane as well, and then just go to the group input and then press Shift A and search for a subdivide mesh node. This will add in some more geometry so that we can deform it, and you can see how much geometry you have by switching over to the wireframe view. Now let's increase the levels all the way to something like 6, and if this is good enough, that's great. You can always increase this further than 6 by just typing in the number if you want. For now, I'll go with 6, and I'll use a subdivision surface later on as well. To actually displace this mesh, we can press Shift A and search for a set position node, and we can control the offset by a noise texture, but the noise texture is centered around 0.5. We need it to be centered around 0, so let's search for a vector math node, switch it from add to subtract, and subtract a value of 0.5 on all of the axes, and plug the color into the first socket and then this vector into the offset. Now it's way too strong, so the first thing that we'll do is reduce the scale to something like 0.5 so that it's nice and smooth, and we'll also press Shift A and search for a vector math node and then change it from add to scale. We'll scale it by a value of maybe 0.8 just to make it much more subtle. Then after the set position, we'll press Shift A and search for a subdivision surface node, plug that in, and that'll make it really nice and smooth. Apart from that, at any point of time, I don't want the actual division lines to be seen, although they can't be seen that well. Just in case, I'll still press Shift A and search for a set shade smooth node, plug that in right here, as well as a set material node so that we can change its material later on. So let's go to the material properties over here, press this plus button to add in a new material. We'll call this floor, and we'll choose floor in the set material. Now let's select our main cube again, and then just hit this pin button so that even if we select something else, the geometry node tree remains. Also, because I don't want to keep playing the simulation again and again and having it rebake, I'll go ahead and just select the actual cube object, go to the physics properties, and under the simulation node section, just bake the simulation. To bake it, you have to save the file. So let's press Ctrl S and save it. So once you've saved it, press bake. So once the bake is complete, you should be able to play the animation and change the start frame to something like 601, which is going to be my final start frame. And that way, we don't have to worry about getting all of these to the proper center region as well anytime soon. Now each of these are currently curves, but they have only 2 points within the curve, which is the start and the end. To actually make all of that much more, we can press Shift A and search for a resample curve node, plug that in, and just increase the count to something like 100. And now there are many more points present for us to actually deform this curve to the shape of this particular plane that we created. But because these are instances, we don't have control over the 100 different points that we just created. To get control over each of those points, we have to press Shift A and search for a realize instances node. Now we can plug that in after the resample curve, and now we have control over each of those points. Let's press Shift A and search for a set position node, and now we have to figure out what the position is going to be for these particular points. So we'll press Shift A and search for a raycast node, and for the raycast node, we need a target geometry onto which the rays will be cast. For that, we already created the plane. So let's take this plane, click and drag it into the geometry node tree, and then change this from original to relative, and take this geometry and plug it into the target geometry. Now the ray direction is already by default -1, which means means it's going on the negative Z direction, and because we want these points to go down on the Z direction, this is perfectly alright. Now we can simply take this is hit and plug it into the selection of the set position, and the hit position we can plug into the position of the set position. So that way we get this particular effect, which is exactly what I wanted. Now I don't want to see this plane, so let's just go ahead and hide the plane for now. Now when you play the animation, you can see how we get all of these points or curves moving through this particular region just like this. If you want, you can select your camera, press Alt G to clear location, Alt R to clear rotation, followed by RX45 to rotate it on the x-axis by 45 degrees, and then press 0 to go into your camera view, and then just press GY to move it back on the y-axis. Then you can go to the camera properties over here, change the focal length down to something like 18, and then slowly increase it till you get the desired focal length, and then continue moving it back in front on the y-axis until you're happy with the positioning of your camera. If you want there to be some more curvature on this particular curves that you created, you can always select the plane again, just unhide it and unpin this so that you go into the geometry nodes made for the plane, and over there for the noise texture scale you can start increasing it to get even more variations in the actual waviness of this plane. Then you can hide the plane again and go back to your cube. Also for this tutorial, I actually have a very low density set on my distribute points on faces node because I'm also recording and my laptop won't be able to handle it. But just before rendering, I would generally delete the bake that I created, increase the density max so that I have much more points, and then rebake it. However, the next thing that we have to do is convert this to a real mesh so that we can actually see it when we switch off overlays, because right now if you switch off overlays, there's absolutely nothing seen. So I'll press Shift A and search for a curve to mesh node, and for the actual profile curve, I'll press Shift A and search for a curve line. Now if we directly plug this curve line into the profile curve, they're obviously not going to be oriented correctly, so I have to change this Z value to 0 and then increase the Y value to something like 0.1, so that way we get these lines present in the correct orientation. But even 0.1 seems way too thick, so I'll change this to 0.02, and now we just have thin lines going around, which looks perfectly alright. Now if you want to see the original speed at which these are actually moving, you can change the playback from play every frame to frame dropping, and that way you'll get a realistic idea of the speed at which it's going to be moving across the screen. Now there's a few things that I need to actually capture about these different lines, and we have to use those in the actual shading tab that we're going to use later. So let's go ahead and capture all the data for these particular splines, because right now we've actually realized the instances, so the object info random is not going to work because all of this is acting as a single object and not instances anymore. So if we want a random color for each of these lines, we have to actually press Shift A and search for a capture attribute, plug that in over here, and change this from point to spline so that every spline gets its own value. The value that we're going to use is going to be a random value, but for the ID of the random value, we're going to press Shift A and search for a curve info node and take the curve ID and plug it into the ID. So that way the instance will make sure that we're getting the same random value for the different curves, and this will also help for the looping as well. If you don't use this, the random value might still be the same for each curve, but the problem is that between frame 1200 and frame 600, the curves are actually different curves, so the random value will be a different value. However, if you use this curve ID, they will still get the same random value and you'll still have the same colors, and it will help in the loop. Now let's plug this into the value of the capture attribute, but because we want to send this value to the shader editor, I shouldn't be using a capture attribute. Instead, I should be using a store named attribute node. So we have to change this from point to spline, plug this value into the value, and just delete this capture attribute node. Now we have to give it a name, so I'll just call it random float because it is a random floating point number. Next, we need to actually store the factor of the spline. That means if we want to get a gradient for each of these lines, we need to know the actual gradient for the individual splines. For that, normally we would use the UV map, but there are no UV maps created for this particular setup that we have. So we just have to store the factor of the spline. So for that, we press Shift A and search for another store named attribute node, plug it in right here. This is going to be for every single point, and it's going to be a float itself, but the value is going to be coming from a spline parameter node, and it's going to be the factor. So let's plug that into the value and name it as factor itself, or FAC. Now the last few things to do just before we go into the material section is pressing Shift A and searching for a set shade smooth node, plugging that in after the curve to mesh, and then pressing Shift A and searching for a set material node. We can plug that in after the set shade smooth and just choose the default material itself because we haven't used that for anything else yet. We can then go to the material properties and rename the material to lines, and then set all of our render defaults by going to our render properties, switching on bloom and screen space reflections. For the bloom, we can actually clamp it down at something like 5, and we can reduce the intensity from 0.5 to 0.02, and we can switch our viewport shading to rendered. Then we can select the default light and delete it, after which we can go to the world properties and change the base color all the way to black. Then we can switch this geometry node editor to the shader editor, and then if we select the main geometry node object, which is the cube, we should have the lines material. So if you can't find the material, just press period on your numpad to centralize the nodes. And now we essentially don't want the principal BSDF, we want an emissive BSDF. So let's search for emission and just plug that into the surface. Now for the color, we wanted random colors based on the attribute that we stored, which was called random float. So let's press Shift A and search for an attribute node. The type is going to remain as geometry because remember, those were realized instances, so it's no longer instance. The name was RANDF and the value was a factor from 0 to 1 itself. So we can press Shift A and search for a color ramp node, and then we can plug the factor into the factor and then just add in the different colors that we want in this particular ramp. So we can control click to add in a new stop, and in case some of the shortcuts that I say don't work, make sure that you have Node Wrangler enabled from your preferences, but we can then choose the different colors. So I'll make this black into a bright blue. I'll change this one to a complete white, and I'll change this last one into a reddish color or an orangish color. That happened by accident, but maybe I'll try orange this time. Then I'll plug this color into the emission color, and you can see how each spline gets its own color. I think there's way too much of white, so let's just start dragging this orange in and dragging the blue in, and now we have quite a good distribution. If you go to frame 1200 and you flip over to frame 600, you should get the exact same setup with the exact same colors for the different lines. Next, we need to play around with the actual bloom or the emission strength. So we press Shift A and search for another attribute node. And remember, this is going to be based on the actual factor of each of the curves. So let's change this name to FAC and then take this factor and plug it into a few math nodes to create a nice gradient. Right now, if you just plug this factor into the strength of the emission node, you'll see you have the nice fall off that goes from the brightest towards the right to a complete value of 0 to the left, but that's not exactly what I want. I want it to be really strong towards this end and then have it fall off to nothing at the end. So I'll press Shift A and search for a math node, and I'll just add a value of 0.5. That's because the next node that I'm going to use is going to be a math node set from add to power. Now what this will do is that any number that is greater than 1 will become very large, and any number that's less than 1 will reduce down to 0 as long as the exponent is something greater than 1. So by adding this value of 0.5, we change the range from 0 to 1 to essentially 0.5 to 1.5. So anything below 1 will start reducing down to 0, and anything above 1 will start going up to a high number. So let's plug this power node after the add node, and I've already increased the exponent to 5.5, so you can start seeing how we have some glow over there and the fade off is much better. Let's start increasing the exponent, and now you can see the really nice glow on one side and the sharp fall off towards the other end. To also see everything much better, let's just select the camera, go to the viewport display and increase passport out all the way to 1. So this is what we currently have. So that looks perfectly all right, but we can make this even better by now taking this plane that we had created and just unhiding it first, and then pressing Shift D to duplicate it, and then just hiding the original plane once again. Now taking this duplicated plane and then pressing GZ to just bring it down underneath the lines. That way we get these really nice reflections, and because we have the floor material added to it, we can make them very metallic, and we can reduce the roughness down to something like 0.3, and that looks really good. Let's just move it up on the Z so it's very close to the lines, and this is what we get. If you feel like the reflection is a bit too strong, you can go ahead and start increasing the roughness, and that way you can adjust the exact effect that you want. I think I'm going to go with a roughness of 0.6. I might change that a bit just before rendering, but essentially that's all there is to this. Once you're happy with the way it looks, you can go ahead and press render animation. I've been searching for how to create something like this for a while, but I really couldn't figure it out. Recently I made a video, this one over here, where we used the raycast node, and I actually made a mistake while explaining the working of the raycast node. So I started playing around with the raycast node a bit to familiarize myself a bit more, and that's when I figured this particular technique out, and I'm actually really happy with it. I hope you all enjoyed it just as much as I did, and I'm really looking forward to see the creative ways in which all of you implement this particular technique. Thank you so much for watching, and if you liked it, be sure to check out other videos on my channels because I post videos every single day, and until the next video comes out, you can keep creating, and don't forget to stay creative.